Science, technology, and the universe will never cease to amaze us. There is always something daunting that transpires. Researchers have accomplished what we call quantum teleportation, and it happens to be the first one achieved over the internet. This historic achievement required harnessing entangled particles to instantly communicate quantum information between two locations. To a certain extent, some might perceive this as a fictional move. However, it is real. It has significant ramifications for communication, quantum computers, and our comprehension of the cosmos. I'll explain how this was accomplished, what it means for the future, and why the universe might not be as we once thought it was or could be. Just to give you an overview and clarification, the ability to transfer quantum information, such as a particle's precise state, from one place to another without actually moving the particle is known as quantum teleportation. Rather, the information is transferred through the use of quantum entanglement and other concepts from quantum mechanics. This idea is about the transmission of quantum states, not about teleporting actual items or people like in science fiction. Information can be instantly shared over great distances without physical transmission, thanks to the phenomenon of quantum entanglement, which is the basis for quantum teleportation. This is what has been taken by researchers to challenge their studies and to understand how the universe and communication function. Some, if not most, of these scientific discoveries and implementations are based on fiction, stories, or films that elaborate on how science works and its connection with the universe. Now, scientists and researchers, because of curiosity, have made some of these fictions come to reality. Professor Prem Kumar, who is in charge of the study of quantum teleportation, said he was thrilled, saying that this is exciting because nobody thought it was possible. Their approach paves the way for the sharing of a common fiber optic infrastructure between next-generation quantum and classical networks. It was necessary to overcome enormous technical obstacles to achieve quantum teleportation. Quantum entanglement, the phenomenon where two particles become inherently linked regardless of distance, is at the heart of this process. The teleportation of information is made possible by the instantaneous reflection of a change in one particle's state in the other. In this groundbreaking experiment, researchers sent entangled photons between two distant locations via fiber optic cables. Researchers were able to prove that information may be transferred without physically moving matter by guaranteeing almost complete fidelity in the transfer of quantum states. The way quantum computers communicate could be completely changed by quantum teleportation. It might create the groundwork for a worldwide quantum network by facilitating instantaneous information transfer, which would allow quantum computers to be seamlessly connected. Applications that were previously thought to be unachievable would be made possible by such a network, which would also significantly improve data processing and solve complicated issues. Another important use is secure communication. Utilizing the ideas of quantum mechanics, quantum teleportation makes sure that data is totally safe and impervious to interception. This might revolutionize sectors, including national security, healthcare, and banking by offering an impenetrable encryption technique and many more. The quantum internet is unavoidable, according to each test, and it will provide computing engineers with a whole new set of tools to measure, monitor, encrypt, and calculate our reality like never before without having to create a new internet. Quantum connectivity between geographically separated nodes could be safely achieved by quantum teleportation. However, a lot of people have long believed that no one would construct specialized infrastructure to transmit light particles. Proper wavelength selection will save us from having to construct new infrastructure. Quantum and classical communications can coexist, and this is something that researchers have managed to identify and prove to us.